everyone, here are your notes for section 3.6. So if you are using your giant packet of skeletal notes, I'm not sure if I included sections 4 and 5 in there, but if I did, just tear them out or cross them out. The only sections that we're doing in chapter 3 are 3.1, 3.2, 3.3, and 3.6. Okay, so this is the last lesson that we're going to be doing for chapter 3. Tomorrow you guys will have a short test on those 4 sections. Okay, so section 3.6 gets us into what theorems we have about perpendicular lines. Section 3.2 and section 3.3 were all of our different theorems about angle relationships that occur when we have parallel lines. So now we're going to look a little bit more into perpendicular lines. We're going to fill out these theorems. We're not going to do all of them. So if it looks like one is there that's not supposed to be there, just cross it off. I forget which ones, or delete it in correspondence to the ones that you have on your notes. So if something looks like it doesn't match up, just don't put it in there. All right, here we go. Let's go ahead and get started. So our first theorem is theorem 3.8. Theorem 3.8 tells us that if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. And again, please pause me at any point in time for you to get caught up with writing these down in your notes. But let's go ahead and make sense of this. So if two lines intersect to form a linear pair, so let's think about that. Here's a line, here's a line. And remember, a linear pair are two angles that are adjacent to each other that create a straight line. So they're supplementary. If those two lines are both congruent to each other, what would they both have to be? Well, for them to add up to 180 degrees and be the same angle, they would both have to be 90 degrees. And what do we know about 90 degrees? 90 degree makes a right angle, right? And what do we know about lines that intersect at a right angle? They are perpendicular. So if two lines intersect to form a linear pair of congruent angles, meaning that they both have to be 90 degrees, then we know that our lines are going to be perpendicular. Theorem 3.9 says if two lines are perpendicular, then they intersect to form 4 right angles, which again should just kind of make sense if we think about it. I have perpendicular lines, which means that they intersect at a right angle. I have a whole bunch of linear pairs. Right here I have a linear pair, so if that top is 90 degrees, then that bottom has to be 90 degrees. Here's a linear pair, so if that right is 90 degrees, then the left needs to be 90 degrees. And then here's another linear pair, so if the right needs to be 90 degrees, then the left needs to be 90 degrees. So if it's perpendicular, then all 4 of those angles created from that intersection will all be right angles, which I'm sure you could have figured that out without having an actual theorem telling you that. Okay, so here's our first example. It says in the diagram, line AB, and then we have a little symbol there that might be new to us, an upside down T. That is our symbol for perpendicular. So that's the shorthand notation for the word perpendicular. You're welcome to use that symbol instead of writing out the word perpendicular. If it was me, I would do that. So line AB is perpendicular to line BC. So what does that mean? So because they're perpendicular, that means they intersect at a right angle, which means angle 2 is 90 degrees. Well, if angle 2 is 90 degrees, then what's true about angle 1? It's also going to be 90 degrees. So what can we conclude? Well, we know that the measure of angle 1 is equal to 90 degrees. We know that the measure of angle 2 is 90 degrees. And since they are both equal to the same measure, we technically could say then that angle 1 and angle 2 are congruent. Because remember, our definition of congruent is that they have equal measures, right? So if they both are 90 degrees, then they have to be congruent to each other. All right, don't make it any more complicated than that. Theorem 3.11, and I think this is where I started deleting some, so you might have some empty blocks as we move forward. Theorem 3.11 says, if a transversal, now remember transversal is a line that intersects multiple lines. So if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. Okay, so let's go ahead and make a diagram of this. So here I have my two lines. If I have a transversal that's perpendicular to one of my parallel lines, remember we put little triangles on the lines like this to show that they're parallel to each other. So if it's perpendicular to the other one and it continues to go through the second parallel line, what this theorem is telling me is that it's also going to be perpendicular to the second one. Why? Well, remember these are corresponding angles. And when my lines are parallel, corresponding angles are congruent. So if that top one is 90, then the bottom one is 90. So that's what this theorem is telling us. So if it's perpendicular to the first parallel line, it's going to be perpendicular to the second parallel line. It would also be perpendicular to a third parallel line. If I added that into the mix, it would be perpendicular there too. Okay. And so then our last theorem that I want you to jot down is kind of the converse of that. Theorem 3.12 says if two lines are perpendicular to the same line, then they would be parallel to each other. So in the last one we had parallel lines, transversal was perpendicular to one, which makes it perpendicular to the other. So here, if your transversal is perpendicular to the two lines, then those two lines that it's perpendicular to would be parallel. So it's the converse, it's the opposite. So if it's perpendicular to both, then the lines are parallel. The last one was if the lines are parallel, then it would be perpendicular to the transversal. Okay, so those are the only theorems that I want you to cover for section 3.6. So if you have extra boxes, just ignore them. And then let's go ahead and do example 3, which says determine which lines, if any, must be parallel in the diagram. Explain. Okay, so remember, in order for lines to be parallel, they need to be perpendicular to the same transversal. So here's a transversal that I have highlighted in green. Here's a transversal I have highlighted in red. Here's a transversal that I have highlighted in blue. So if I look at the blue one, do I have any perpendicular right angle boxes there? Nope. So U is unnecessary information. I have one right angle box on T, but I don't have two. So T is not what I want to worry about. But now look at S. Notice I have two right angles there. So because P, let me get rid of all this stuff. So because P is perpendicular to S, and because Q is perpendicular to S, and they're both perpendicular to the same transversal S, then we can say that they are parallel. So I'm going to say that P is parallel to Q. Okay. All right, so now let's look at another situation that could occur. Let's look at our up and down lines to see if any of those are parallel. So now think about P being a transversal. Well, I have S being perpendicular to P, but T is not perpendicular to P and U is not perpendicular to P. So P is not going to be helpful. Now let's go down and look at Q. Notice S is perpendicular to Q and T is also perpendicular to Q. So because both S and T are perpendicular to Q, they are going to be parallel to each other. So I'm going to write S. Remember, this is our symbol for parallel, the double bar, two double lines. So S is parallel to T because they are both perpendicular to Q. U would not be parallel to anything because there is no right angles anywhere occurring at line U. Okay. All right, so now I think that should end your notes. So what I would like you to do before we end all of our notes is if you have a piece of scrap paper handy, we're just going to go through and work a few practice problems to see if you have an idea of what's going on here. All right, so pause if you need a pause. If not, if you got your practice space ready, let's go ahead and start. Okay, so can you tell me the measure of angle 1? Hopefully you said that the measure of angle 1 was equal to 25. To get that, we know that those two angles need to add up to 90. So 90 minus 65 gets you to 25. Next one, tell me the measure of angle 1. Hopefully you said 90, right? Vertical angles are congruent, and plus since I have perpendicular lines, all 4 angles around will be right angles. Find the measure of angle 1 here. Hopefully you said it was 52. 90 minus 38 gets you to that 52. Tell me what x would be equal to here. They would have to be all 90, right? Which then would make the lines parallel to each other. All right, now you got a little bit of thinking here. You're gonna have to do a little bit of math. So now what I need you to do is solve for x by setting up your equation. All right, so hopefully what you did is you did 63 plus x plus 14 equals what? 90. Why do I know it's 90? Well, because it told me in the directions that they are perpendicular, which makes this whole entire angle 90 degrees. So then 63 plus 14 makes 77 plus x equals 90. Subtracting that from 90 gets you x to be 13. All right, let's try another one of those. Solve for x. So again, hopefully you did x minus 25 plus 20 equals 90. Combining like terms gets you x minus 5 equals 90. So x is equal to 95. That would have been your final answer. All right, next one. Solving for x. Hopefully you got, I think it should be 33. So 2x minus 9 plus x equals 90. Combining like terms, 3x minus 9 equals 90. Adding 9 gets you 3x equals 99. Dividing gets you x is equal to 33. Good. All right, next one. Looking at this diagram here, it's kind of hard to see the square boxes and the angles, but hopefully you can see them. Determine which lines, if any, must be parallel. Please check all that would apply in the multiple choice question. Hopefully you said that V and W are parallel to each other because they are both perpendicular to the transversal of Y. Oops, don't get rid of that, VW. And then hopefully you also said that it looks like line W and X are going to be parallel to each other because they are both perpendicular to transversal Z. So W is parallel to X. And then we need to make that decision of whether Z and Y are parallel to each other. So Z and Y. Well, Z is perpendicular to W. Is Y also perpendicular to W? Yes, it is. So right there we have enough proof to say that Z is parallel to Y. Are V and X parallel to each other that we know of? So V is perpendicular to W. Here we go, V. Checking on V and Y. So are they perpendicular, not V and Y, V and Y. V and Y. So V is perpendicular to Y, but X is not perpendicular to Y. And X is perpendicular to, or sorry, Z is perpendicular, or X is perpendicular to Z, but V is not perpendicular to Z. So those would not be parallel to each other. All right, that concludes your notes. Hopefully you got a handle on that. Move on to your next assignment. Bye, guys.